Have you ever been driving and stuck behind a truck that says wide load ahead? After this episode, you might just see it differently as there are a wide variety of load switches ahead. What is a load switch? It's right there in the name. It is a switch designed specifically for turning loads off and on. Now think of your average mobile phone. It's a battery-powered device, so saving power whenever possible is necessary to get the longest battery life. Of course, you can select the lowest power devices to include in the phone, but even in standby mode, each consumes some small amount of that valuable power. The ultimate way of saving power is simply to turn off or disconnect the devices when they aren't needed. For example, your phone has an RF section for the phone, but it also has a Wi-Fi transceiver and likely a Bluetooth transceiver as well. Now, not every application needs all three of these RF sections to operate at the same time. So load switches can be used to simply turn off the sections that are not needed. Same thing for the displays. There's power needed for the color LCD display, for the backlight, and the touchscreen on top of it. Since you don't need any of these when you have the phone pressed up against your face during a phone call, shut them off. There's also audio and video functions like the speaker amplifier and the processor, the camera and the flash unit that certainly aren't needed all the time. Load switches to the rescue. If you don't need a function, even for just a short amount of time, use a load switch to disconnect it and save that precious battery power. A load switch is really just the latest member of the family that started with that old familiar device, the mechanical switch. Just like the wall switch in your house, it switches the load, in this case, the room lights. Now, it takes a mechanical force, the force of your finger, to turn on that mechanical switch. Since a computer doesn't have a proper finger, there was a need to create a device which allowed an electrical force to close the switch. Now, this is known as the electromechanical relay, which converts the electricity to magnetism to pull the switch contacts together. Relays are great, and they're still used extensively in industrial applications. But they can be rather large and noisy, and they have a limited lifetime. So a semiconductor equivalent was invented, the FET, or the field effect transistor. A FET essentially duplicates the electrical contacts inside a mechanical switch or a relay with semiconductor material. Apply the right voltage to the gate, and the current flows between the source and the drain. FETs can be made very small, and since they have no moving contacts inside, they can be made very durable. A FET is really good at switching a load off and on. However, sometimes that just isn't enough. There are more power switching functions besides simply off and on. And thus was born the intelligent FET, or the load switch. Now this is the diagram of the inside of the simplest type of load switch. The FET M1 is the workhorse. It controls the main power through the load switch from the input voltage side to the switch voltage side. The resistor R1 is used to bias the gate of the FET. Now this means pre-applying the proper amount of voltage to the gate so it's right on the edge of turning on. Just a little bit more voltage from the control input line and the load switch will turn on. There's also typically a second FET inside, in this case the FET M2. This is there because of the nature of the FET M1. It switches the load on when its gate is a binary low. Now this is sort of backwards logic. For convenience and safety, you really want a high signal on the control pin to turn on the load switch. This FET M2 provides this inverter function, and it makes the logic work out and also makes it easier to connect this to the rest of the control circuit. So with just a couple simple parts, you have an effective load switch. Your microcontroller or some other electronic circuit can apply a small logic level signal to the control input pin and cause a much higher load as big as many volts and many amps to be switched. But when you start switching these higher voltages and currents, things can get a bit tricky. What happens if there's a short in the output? That giant FET can supply a large amount of current that, if uncontrolled, could overheat and theoretically start a fire. What if the batteries in the toy are inserted backwards by mistake? Will they go back and damage the entire circuit? With just a bit more circuitry, the load switch can become smart enough to handle these conditions as well as others, which is where the real value of a load switch appears. Now this is the block diagram of one of these sophisticated load switches. It is a combination of many of the advanced features that designers are looking for in power control. Let's look at it one section at a time. For all its apparent complexity, you can still see the heart of the basic load switch here. The input power, the output pin, and the main FET that connects them all together. The driver logic section can provide more than just the simple inverting of the input control voltage. When the load switch first turns on, there can be a very large surge or spike of current through the system. In many cases, it's useful to not slam the switch on, but to gently turn it on. Just like using a dimmer to gently turn on your room lights, this helps protect the light bulb from that sudden surge of on current. This is known as slew rate control and is a common feature in many load switches. FETs can get a bit finicky at very low voltages. Without enough voltage on the gate, they just don't turn off or on reliably. Many applications in mobile phones, for example, need to operate at only a few volts, right near the lower limit of the FET operating. So to make the load switch work reliably at this low voltage, a charge pump can be added to boost the gate voltage internally to the proper levels. Sometimes though, even with the charge pump, the voltage is just too low for the FET to operate correctly. In this case, it's useful to have a protection circuit called the under voltage lockout, which, like the name implies, simply shuts down the entire load switch if the supply voltage goes too low for even the charge pump to work. When a load switch turns off, this doesn't necessarily mean that the voltage on the output side goes immediately to zero. Depending on the load and the capacitance there, it may take some time for that voltage to gradually drop down to zero. Now, digital electronics don't like slow ramps very much. They would rather be completely powered on or completely powered off. To help with this, a feature known as a discharge circuit can short the output to ground when the main FET turns off. This sends all of that stored charge right to ground, and the receiving device sees 0 volts, just like it expects. Another safety feature that is common in load switches is thermal protection. Semiconductors can be damaged when their internal temperature approaches about 150 degrees C. A thermal circuit inside can safely shut off the load switch well before any damage could occur. Ever accidentally put the batteries into a toy backwards? If you were lucky, no damage occurred. A reverse voltage protection circuit can be added to a load switch to guarantee that the switch is safely opened in case this happens. One of the most desired features in a load switch is current limiting. Just like a circuit breaker in your house, if the current through the switch goes above a preset limit, the switch opens up, or in some cases it actually becomes a current regulator to keep the current flow right at the maximum allowable value. With all of these advanced features on board, it can be very useful to know exactly which reason caused the load switch to shut off in the first place. The fault pin can send anything from simple to advanced data back to the main processor, reporting on why the switch just turned off. So what does a load switch actually look like? This is a common example, the NX3P190/191 switch. It's one of the simpler ones. It has slew rate control and an optional discharge circuit. It can switch up to 3.6 volts at a half amp, which is a good size for the various components you might want to control inside a mobile phone, for example. The really impressive part is the size of this package. That 4-pin device is only 0.8 by 0.8 millimeters. That is smaller than the head of a pin, so it can fit just about anywhere. There you have it, the load switch. From simple to sophisticated, it can provide you the ultimate in power savings. Remember, if you don't need a device, disconnect it. And remember, keep an eye out for those wide loads.